All right, this is the second page of the notes, trigonometric functions. You guys have heard of sine, cosine, and tangent for sure. You may have heard of cosecant, secant, and cotangent, but you maybe haven't. And so we will definitely talk about all six of these. A trigonometric function is a function whose rule is defined by a trigonometric ratio. A trigonometric ratio compares the length of two sides of the triangle. The Greek letter theta, so theta looks like this and is written like this, is used to represent the measure of an acute angle in a right triangle. So in the triangle that they have over here for us to look at, you can see theta is down here at the base of the triangle. But since both of these angles could be acute, theta could represent either of those angles. So just be careful when you're doing these problems that you know where theta is when you're working. All right, so for sine of theta, for the triangle that we have here, it is, sine is always opposite. Whoa, what just happened? My pen just did not work. Is always opposite over hypotenuse. And so for this problem, that would be A over C. All right, so opposite of theta means if you look across from theta, what side are you looking at? And then the hypotenuse is always opposite of the right angle. So just wanted to make sure that makes sense. For cosine, we're talking about adjacent over hypotenuse. So that would be B over C. So adjacent is the leg that helps make the angle. So one of the legs is the hypotenuse. So we're not talking about that one. That's the C part. So adjacent means that this leg made part of theta. So that's where that comes from. And then tangent is opposite over adjacent. Tangent is the one that's easier to remember because it doesn't include the hypotenuse. It's like the special one. So it's A over B. So opposite over adjacent. And then the reciprocal functions are just the previous three functions turned upside down. So you can see here that they're represented like cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. So cosecant would just be hypotenuse over opposite. So it would be C over A. And secant would be hypotenuse over adjacent. So it would be C over B. And then cotangent is adjacent over opposite, which is B over A. So those again, I don't believe, yeah, they're not really on your reference sheet, but you could definitely write them on there if you need to keep those in your brain. Again, this is something that we try to encourage you guys to remember, have that memorized so that it's quick and easy for you to access that information in your brain. One of the ways we do that is by talking about SOHCAHTOA. So, SOHCAHTOA, sine is opposite over hypotenuse. So we've got there, those are letters are in order. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So SOHCAHTOA is where that comes from. It doesn't work as nice with cosecant, secant, and cotangent. You just have to. One thing that will help you remember this is that the reciprocal of sine is the other one with the co, and the reciprocal of cosine is the one without co. So that's kind of how I remember them, is it's not really the one you think it would be. And then tangent does go with cotangent. So that's very nice. I mean, and these people could have named this stuff anything. So sometimes you wonder where did these words come from? All right, so if we were going to look at some examples of this, find all 6 trig ratios for theta shown in the triangle below. So this line right here separates this into 2 different problems. I feel like the way that this table is on here, you're kind of like, I don't even know what I'm looking at. So number 9, we're going to work some stuff out and fill in these 6, and then for 10 we'll fill in the other 6. All right, so the first thing you have to do is you have to find the hypotenuse. Otherwise you can't fill up these tables and know what the answers are for the ratios. So we're going to do 16 squared plus 30 squared equals x squared. So you get 256 plus 900 equals x squared. So that's 1156 equals x squared. And so that our life is easier right now, that is a perfect square. The square root of 1156 equals 34. So when we fill these in, we're going to start and just go through all 6 from up here. So sine is opposite over opposite over hypotenuse. So theta being down here in the bottom, the opposite is 16. So we're going to have 16 over that 34 that we just found. Now, that can be simplified, so make sure you are simplifying your fractions. If you want to use a calculator to do this, I certainly do not care. Now, what makes this easy for the right-hand column is the cosecant is just the reciprocal of sine. So you can just work and find sine, and then cosecant is the reciprocal of that, so you don't have to work it out a second time. Cosine is adjacent over hypotenuse, so that is, of course, the leg that helps make theta over the hypotenuse. So 30 over 34, which simplifies to 15 over 17. And then the secant is the reciprocal of that, so that's 17 over 15. And then tangent is opposite over adjacent, so 16 over 30. 16 over 30 simplifies to 8 over 15. And then the cotangent is the reciprocal, so 15 over 8. All right, so pretty simple there. Now, number 10 says, given the ratio for cosine theta, find the remaining ratios. I'm just looking at this and I'm seeing that the question does not give us enough information. So it appears that the cosine is supposed to be 2/3. So I don't think it told us that there was 2/3. So this is what they wanted us to do, is to draw this triangle. This is the right angle part, and this is theta. And so 2/3, this of course would be the hypotenuse, and cosine means the adjacent one, so 2 goes there. And so then we have to find the other leg. That's so strange that it just left out what the ratio was. Good thing that I was prepared and had my old notes here. So we're going to fill this in with the information we know so that we can find that missing leg. All right, 5 is a prime number, so that means that the missing leg is the square root of 5. Yuck. Okay, so, but that's all right. So what we're going to do is we're just going to use this information. Oh, it was 2/3 was right there. I was working too hard. Dang. Okay. So then the sign is going to be opposite, which is square root of 5, gosh, over hypotenuse. And tangent is going to be opposite over adjacent. So those are easy. Secant is also easy because it's just 3 over 2 because we just flip that cosine. However, cosecant and cotangent, we're going to end up like this with a radical in our denominator, which we cannot have. So we're going to have to multiply both top and bottom by the square root of 5. So that's going to give us 3 square root of 5. And then square root of 5 times square root of 5 will leave us with 5 in the denominator. Same thing for cotangent. 2 square root of 5. And square root of 5 times square root of 5 leaves us with 5 in the denominator. All right. So, sorry I freaked out on that one. I just wasn't looking clearly enough. All right. And so, sometimes we will have these special right triangles in addition to our trig ratios. And because they have a special relationship, those trig ratios have a special relationship. So you can see here it says angles of 30, 60, 90, and 45, 45, 90 are used frequently. You can use your knowledge of side relationships and special right triangles to find values of the trigonometric ratios. So all of these, like a sine of 45 degrees or a cosine of 30 degrees, are something that you would be asked in a normal situation. So the first thing we need to know is what we learned in the last video, that these legs are x and the hypotenuse is x square root of 2 for the 45s. For the 30-60, the short leg is x, the hypotenuse is 2x, and the long leg is x square root of 3. And so we can set these up from there. So the sine of a 45-degree angle, you would have the x, so it doesn't matter, they're both x, over the hypotenuse, which is the x square root of 2. Well, we cannot leave that. So we have to do square root of 2, multiply both the top and the bottom by square root of 2. And so we get x square root of 2. This is not enough room. And then 2x, because square root of 2 times square root of 2 is 2. Well, then the x's cancel out. So it is square root of 2 over 2 is always the sine of a 45-degree angle. I'm going to try to make these a little bit smaller. Cosine is the same because cosine of a 45-degree angle, it doesn't, opposite and adjacent are the same. So it would still be x over x square root of 2. You would still multiply so that you could get x square root of 2 over 2x. X's cancel out, and so you're still left with the square root of 2 over 2. So sine and cosine of a 45-degree angle are both square root of 2 over 2. Tangent is even more fun. Opposite over adjacent, x over x is 1. So the tangent of a 45-degree angle is just 1. So those are really one of those things, again, you need to commit those to memory. All right, sine. So if depending on where the 30-degree angle is. So if you're doing theta is 30 degrees, then we're talking sine of 30. But if theta is 60 degrees, we're talking sine of 60. So there's two sets for 30, 60, 90. So the sine of 30 would be x over 2x. So the x's simplify to 1/2. The cosine for 30, so it would be adjacent, over 2x. The x's cancel out, and you have the square root of 3 over 2. So the tangent of 30, now this one less fun than the last time we were with tangent. You have x over the x square root of 3. So you have to multiply by the square root of 3. And so you get x square root of 3 over 3x. So kind of like sine and cosine of 45, the x's cancel out and you're left with the square root of 3 over 3. Like that. Okay, so what if we have the opposite setup and we're talking about the sine of 60? Well, the sine of 60 is x square root of 3 over 2x. And so the x's cancel out and you have the square root of 3 over 2. Same as cosine of 30. That should make sense to you because now we're doing opposite over adjacent on the opposite angle. So that should make sense. Cosine is this time x over 2x, which will give us 1/2. So again, we're doing cosine of the opposite angle, so it's going to give us the same as what sine was. And tangent is flipped upside down this time. So tangent of 60 is now opposite, sorry about that, opposite over adjacent. So you have x square root of 3 over x, which means when the x's cancel out, you're just left with the square root of 3. So that one is nice as well. All right, so write these down. Try to remember them because they will help you later.